Hello, in this video I will discuss on the topic multifaceted impacts of green chemistry in sustainable development. So I will briefly try to describe the relation between green chemistry and sustainable development.
The term sustainable development was first introduced in the paper Our Common Future, released by Brundtland Commission. Sustainable development is a kind of development that meets the needs of the present without compromising the ability of future generations to meet their own needs. In this context, I would like to cite the 7th generation sustainability law of the Iroquois nation, which says that in every deliberation we must consider the impact on the 7th generations. The three most main interdependent and mutually reinforcing pillars of sustainable development are economic growth, environmental protection, social equality. Three principles are also informally used as profit, people, and planet. Now, let us check what is green chemistry. As per the definition provided by Anastas and Warner, the green chemistry is the utilization of a set of principles that reduce or eliminate the use or generations of hazardous substances in the design, manufacture, and application of chemical products. Green chemistry involves the design and redesign of chemical synthesis and chemical products to prevent pollution and thereby solve environmental problems. Here I have shown 12 principles of green chemistry as formulated by Warner and Anastas. Here I have shown some important aspects of green chemistry such as catalytic process, use of renewable feedstocks, safer reactions and reagents, etc. So, green chemistry provides solutions to such global challenges as climate change, sustainable agriculture, energy toxics in the environment, depletions of natural resources. As green chemistry shows a fundamental approach to pollution prevention, so it is a tool in achieving sustainability. It is very important to learn and build a sustainable culture for the long run of human civilization. Sustainability is a way of thinking and the students should practice it, as it is well accepted that green chemistry is a very important tool for a sustainable future. So incorporations of sustainable thinking in experimental design in undergraduate chemistry course is very much required. The traditional approach should be revised and replaced by green approaches. The students should understand and be aware of environmental contamination and chemical exposure. We must educate the students about green chemistry in a way that encourages application of their own knowledge. So, here I am going to discuss two alternative synthetic methodologies that can be practiced in the undergraduate chemistry laboratory. In the undergraduate chemistry laboratory for the detection of the special element such as nitrogen, sulfur, chlorine, we usually follow the Lassine test method when metallic sodium is used for the fusion at high temperature. The biggest problem of this method is that metallic sodium is highly reactive and catches fire in open air, so the students face a lot of problem while handling it. So I recommend to perform the same reaction using zinc-sodium carbonate instead of using metallic sodium. You can consult this book by Mann and Sanders to know how to prepare zinc-sodium carbonate. So what are the advantages of using zinc-sodium carbonate mixtures in terms of green chemistry? Number one, extremely safe as there is no risk of explosion or getting caught fire. Number two, no additional precaution is needed during its storage for a long period of time as it is chemically unaffected by radiant oxygen and moisture. Number three, experiments can also be performed with aqueous solution of organic compound, but you know that sodium cannot be used in aqueous solution because it immediately catch fires. Another one experiment that can be introduced in the chemistry undergraduate laboratory to teach the students about the essence of green chemistry is the benzylic acid rearrangement in solid phase condition. This reaction is very easy to perform. You can just take solid KOH, benzene and mix it at and heat it. The green context of this reaction is solvent free, easy process, time saving, cost effective. So thank you all of you for listening me carefully.